going to look at the series from n equals 3 to infinity of 2 to the 3n minus 1 divided by 3 to the 2n minus 2. Our goal is to determine if this series converges or diverges, and if it converges, what does it converge to? Note that this series starts at 3, so we have to be very careful to make sure we use the right formula to determine convergence. So this can be rewritten, the series, as the summation from 3 to infinity, 2 to the 3n times 2 to the minus 1 divided by 3 to the 2n times 3 to the minus 2. And now this further can be written as the summation from 3 to infinity. 3 to the minus 2 in the denominator is 3 squared. 2 to the minus 1 in the numerator, that would be divided by 2. And then 2 to the 3n we can write as 2 cubed to the n divided by 3 squared to the n in the denominator. So let's write this in this form. From 3 to infinity we have 9 halves, and then 2 cubed is 8 divided by 3 squared, 9 to the n. So this is a recognizable series. It's geometric. R, the ratio between terms, is 8 over 9, which is less than 1 and greater than minus 1. This means that the series is going to converge. But now we have to determine what it will converge to. When a series starts at 3, its standard form is a times r raised to the n minus 3 power. So that when n is 3 we get a, when n is 4 we get a times r, when n is 5 we get ar squared plus ar cubed, and so on. And this will add up to, converge to, a divided by 1 minus r, provided that r is less than 1 and greater than minus 1. So to use this formula, the series has to be in this form. The series we have is not quite in that form. So here's what we can do. Here is our series. It's the summation from 3 to infinity. It's 9 halves and then 8 over 9 to the n. We're going to factor out. So we start at 3 to infinity. Here's 9 halves. We'll factor out 8 over 9 to the third power, and that will leave 8 over 9 to the n minus 3 power, which is what we need. And now we have to simplify. If I take 9 halves and then 8 over 9 cubed, that's 8 times 8 times 8 divided by 9 times 9 times 9. So we can cancel one of the 9's here, and 2 and 8 puts a 4. 8 times 8 is 64. 64 times 4 is 256. So this is 256 divided by 81. Therefore, in standard form, our series looks like this. The summation from 3 to infinity, 256 divided by 81 times 8 over 9 to the n minus 3 power. And now we can use the formula. Our a is 256 over 81, and that's divided by 1 minus 8 over 9. So this is 256 over 81 divided by 1 over 9, and this is equal to 256 divided by 9, which is the final answer. To summarize then, the series that we started with, that was n equals 3 to infinity, and we had 2 raised to the 3n minus 1 power divided by 3 raised to the 2n minus 2 power. We were able to write it in a standard form for a geometric series that starts at 3, and that was 256 divided by 81, and then times 8 over 9 to the n minus 3rd power, and this series converges to 256 over 9. Now, we could arrive at this answer in another way. Again, we start with the series n equals 3 to infinity, and that series was 2 to the 3n minus 1 divided by 3 to the 2n minus 2, and we were able to express this series as 9 halves. So this is the summation from 3 to infinity, and then we had 9 halves, 8 over 9 to the n. Now, if instead of proceeding to the standard form by factoring 8 over 9 cubed, we can do the following. A geometric series where r is known to be between -1 and 1 will converge to the following. First term divided by 1 minus r. So right from here, to find the first term, all we have to do is plug in 3 for n, which is 9 halves times 8 over 9 to the third power, and we already computed that. So this was 256 divided by 81, and then we get the same answer by using this formula. The answer is the first term, which is 256 over 81 divided by 1 minus 8/9. So this is 256 divided by 81 divided by 1 over 9, which is 256 divided by 9, the same answer that we got before, because we're really doing the same thing. For